Welcome to Brain Vision.
Hello everyone. So for this question we have been given a reaction energy diagram over here, and we need to first of all answer the activation energy for the step B to A. Then we have to calculate the overall energy change for the process C to B, and then we need to know which step is faster, A to B or C to B. First of all, for any given reaction, the reactant A collides with its own molecules and gains some energy to form an activated complex. Now this is also the minimum energy required for the reactant to be converted into the product B, and this energy, the minimum energy required, is called as the activation energy. So if the activation energy is possible to achieve, the reaction is possible and A will transform into B, and otherwise the reaction is not possible, and this energy is measured in kilocalories per mole. The values given here are this: A is over 5 kilocalories per mole, this C is over 8 kilocalories per mole, for the B it is 12 kilocalories per mole, for the activated complex of A and B it is 18 kilocalories per mole, and for the activated complex of B and C it is 24 kilocalories per mole. Now for the activation energy required from A to B will be equal to the Gibbs free energy of the activated complex minus the Gibbs free energy of the product B, and therefore it will be equal to 18 kilocalories per mole minus 12 kilocalories per mole. The values are given in the graph, so it will be equal to 6 kilocalories per mole. That is the activation energy from A to B. That is the first part. Now for the second part, we have to calculate the overall energy change, that is the delta G, for the process C to B. Therefore delta G for C to B will be equal to Gibbs free energy of the final position, that is for the product B, minus the initial, that is Gibbs free energy for reactant C, which will be equal to 12 kilocalories per mole minus 7 kilocalories per mole, and that will be equal to 5 kilocalories per mole. So that will be the delta G, that is change in overall energy from C to B. Now we have to find which reaction will be faster. For this we have to find the activation energy from A to B. So A to B activation energy will be equal to the Gibbs free energy of the activated complex minus Gibbs free energy of the reactant A, and that will be equal to 18 kilocalories minus 5 kilocalories, that will be equal to 13 kilocalories per mole. And similarly for C to B, the activation energy will be similarly 24 kilocalories minus 8 kilocalories, and that will be equal to 16 kilocalories per mole. Now since lesser the activation energy, faster will be the reaction. Therefore we can say that this reaction, that is the reaction A to B, will be faster. Therefore A to B will be a faster reaction. So that's it for the question. I hope everything is clear to you. Thank you for watching the video.